on to the next presentation. I think this is the last presentation of the session. This is coming from Christian Comas, who is Head of Business Development Europe at Huasun. Christian is going to speak about vertical PV and batteries, maximizing the market value of PV in the next decade. Christian? We cannot hear you.
Can you hear me now?
Yeah.
Perfect. Sorry about that. So hello, everybody. Let's go with the presentation. Today we want to talk about, let me share the screen, vertical photovoltaic, but not in a vacuum, but instead we want to talk about vertical photovoltaic in the landscape of possibilities that we have in order to make a PV plant. So we are going to have a very deep comparison in terms of profitability from vertical and other topologies, including batteries, so that we leave nothing outside and we try to be as fair as possible. So we want to analyze why one option could be better than other options, and that you should, at the end of the presentation, know when and how, so that you can choose for yourself in your own country or your own market what you want to do. Just a second. First, we will go very briefly about our company, then why we're talking about this analysis, and we'll go to the summary at the very end. I hope everybody knows Huasun by now. We are the largest manufacturer of heterojunction solar modules, even though compared to, let's say, the big five biggest manufacturers of solar modules, mostly TOPCon, we are relatively small, but 20 gigawatt for heterojunction, well, is the largest so far. We have a nice roadmap that includes perovskite tandem for the future, but today we're not talking about us, we're not talking about our portfolio, we're talking about vertical PV. For vertical installation, we have a specific product series called Kunlun. Kunlun is a mountain in China, very high. And those are made specifically for vertical. You saw in the presentation earlier today how a design that puts the junction boxes in different places, that turns around the solar cells, is more convenient for vertical installation. And we have that, and we have had that installed on the fields in several generations since 3 years ago. So it's already a very mature product, not a prototype. We have as well solar modules of more classical design for vertical installation. And the key point here is that for all of these, we have on the rear side UV protection through light conversion film to protect the cells, anti-reflection glass, and all of the things that make the module very reliable. So that's enough about us. Let's go for why we are talking about this, why we think we need new topologies of solar plants. In markets that have become mature, photovoltaic has taken a big part of the generation of electricity. This is just a graphic from California, and you can see that it's become the largest source of energy. Similar things are happening in Europe. For instance, in Germany, I think we are over 17% of all of the used electricity is made with solar. What happens when you have a lot of generation is that most of this is not made on the market just selling the energy. Most of this has been installed with some kind of tariff, some kind of auction, some kind of feed-in tariff. That means that this energy from solar is not going just to be sold normally. What this means, in this graphic you see the generation at different times of the day, is that the actual demand of electricity from other means, not solar, for those companies that actually buy electricity in the market to sell it to customers, that demand is going down specifically for the central hours of the day. And what happens when demand goes down is that prices go down. This is caused not just by supply and demand, but by the fact, technical fact, that almost every fossil fuel plant has difficulties to ramp up and ramp down. It's either technically impossible, like in nuclear, or difficult, like in coal, or you reduce the efficiency, like in coal and gas. So they don't want to do that. So they are they are willing to reduce the cost even below the generation cost during the central hours of the day just to sell the electricity. And this overall reduces the prices on the market. Not just in California, where you can see now the prices decreasing from 2015 down to 2022 in the central hours of the day, but this happens as well in markets such as in Germany. How you see that now in this graphics is that the central hours have this bottom down and it's getting deeper and deeper. We are not yet in this kind of situation like in California, where you can see average prices almost at zero for hours, but we are getting there. And every market, like in Spain and every other market that has a lot of electricity from solar, is going in this direction. Why this is important is because if you see the installation facing south, well, at least in the northern hemisphere, facing south, that we classically have, because it's very cheap to install, it's very reliable, nothing happens, very low maintenance, that generation concentrates in the central hours of the day, exactly where the prices are the lowest. What happens then is that if you want to install plants outside of the protection of a feed-in tariff, where you get in the feed-in tariff all the money regardless of the situation on the market, if you want to go to the free market where the huge market is for PV plant and electricity, you will have difficulties justifying to your investors that you're going to make any money with the plant, because very soon this bottom of the price level on the market will be lower than your levelized cost of electricity, which means that you may not be doing any profit. And this is a trend, which means that what we have seen in the past will be even more reinforced in the future. So, what are the topologies? What are the solutions that we can have in order to mitigate as much as possible this? The typical point that everybody talks about is to put batteries. And today what I will do is to consider the four main installation method topologies. This is fixed tilt facing south, or trackers, or dome, which means facing east and west, one side facing east, one side facing west, but quite flat, or vertical. And I'm going to compare each one of them to each other, and I'm going to compare that to each one of them using a battery system. This for utility scale with all the costs, with the simulations done in PVCs, with certified PAN files, everything done properly. So the first point is about the cost, and it is no surprise to anyone that if you look at the CapEx, this means the actual cost of the total system, including things like permits and project rights and things like that. The cheapest is the fixed tilt, and very, very close is the dome, because it's very similar. It just has a little bit more complexity, but trackers are much more expensive. And vertical, for the moment, is more expensive as well. Part of this expensive point of vertical is that our solar panels, heterojunction, are a little bit more expensive than TOPCon. This is included in this calculation, but still this CapEx is lower than a tracker system made with TOPCon. If we look at batteries, in this case, we have taken a reasonable battery of half of the capacity in kilowatt hour compared to the kilowatt peak in DC that the solar plant has. This is made so that we are sure that this battery gets a lot of use, so the cycles per year are around 300 or more, so that we are not having a battery that is underutilized. This price I have taken from some tenders that are going on, and this price is quite aggressive. It is 140 euros per kilowatt hour, all inclusive. Everything installed, everything work done, everything. So that's quite aggressive, but we think that it will be realistic for utility scale in 2025, 2026. So you install something that costs more. But this cost is not just the first day. You need to look at the OpEx, operating cost. And here, the operating cost of dome and fixed tilt is the same, or at least I assume is the same. Maybe it's a little bit more difficult to grab things in dome, but let's forget about it. Vertical, I have assigned a higher cost, not because you need to do more cleaning stuff, in the contrary, you need to do less, but you need more land. You need to rent more land. So that is going to affect it because your GCR, your ground coverage radio, is lower. This affects as well the trackers in a very similar way, but in trackers you have higher costs as well because it is a tracker. In this point, I want to say that there is a big question mark about what are the real costs in operation of trackers, because we need to think if we take into this consideration as well things like downtime. For the moment, I didn't take it, but those who run plants, both fixed tilt and trackers, should think about it and just make your own calculations. If we have a battery on top of that, we need to take care that battery systems are a new piece of equipment that needs operating costs. This means from the technical point of view, you need to take care of the safety, you need to do inspections, you need to do everything related to the battery. So this is going to increase your OpEx a lot. Unfortunately, there is not experience of 10 years about what is the OpEx of a battery system, and the quality and the reliability of different battery systems is very different today because we are only starting. So this will be better known in the future. For the moment, of course, to be fair, I assign the same battery OpEx to each one of the topologies because, well, it's going to be the same. So, what about the yield? There is no surprises. You can just do in your simulation tool this simulation and you will get very similar results. This is for Munich in Germany, and you get about 20% more yield for trackers compared to fixed tilt, and you get much less, about 10-12% less yield if you do dome. This means east-west. You can replicate this by yourself. I have made this simulation several times, including doing the simulation first doing only the west part, then doing only the east part and combining them. One of the key points of the dome is that the bifaciality is much worse because you have not as much of the rear side of the panel exposed to the sunlight. If you go vertical, this result is with heterojunction from us, because these vertical panels that we're making, the Kunlun, they have more than 95% bifaciality. This means basically that this is the top vertical panel that you can use. And in that case, if you use, like in this simulation, that is the same simulation as for the cost of OpEx, you separate these rows by 11 meters, you get actually more yield compared to the south-facing system. And this, well, is a very good result. If you look at the same systems with battery, it's basically the same, just a small reduction because batteries have some efficiency that is not perfect. So when you save some energy in the battery and take it out later, it's not 100%. But when you do all the calculations, this does not affect very much the overall energy fed into the grid. So now we come to the money. How much money do you get from those systems that produce at different times of the day? The key point here is that the tracker and the vertical are going to be producing energy in times where the fixed tilt is getting very little amount of money. So the fundamental income from trackers is much higher and from vertical as well. From dome, unfortunately, is not so much higher. If you go to maybe a situation in which you have at the equator where the sun really goes out on the east and goes down on the west every day, maybe you get less losses compared to south facing in a dome situation. But in Europe, especially in summer, the sun is not really on the east going to west, it's a different curve, and you can do the simulation, you can look at the daily curves, and basically it doesn't work as much as you would expect if you just do east-west. If you look into batteries, you see that you have about 15% more income when you have this battery set. So now, obviously, the thought is how is this going to play as profitability? So the first step we need to do is to reduce this income by the OpEx that you have. So what is the net income per kilowatt peak? And now we have applied the fact that some of these plants have well, higher OpEx. And you see that battery systems are a bit more, well, they have more income net than the non-battery system. So that looks good. But the difference have reduced a lot because you have a lot of OpEx, or probably you will have a lot of OpEx. In terms of what is the profitability of the other topologies, you can see that horizontal facing south and dome situation is very similar, but the improvement from profitability from tracker versus vertical has reduced dramatically. In terms of systems with battery is quite similar. But now you need to look at that from maybe another perspective. How much of your initial investment are you getting as net profit every year? This is very similar to looking at the IRR, but in a more simplified way. So if you invest 1 million euros, you get, in the first case, 11% of this, so 110,000 euro every month, every year as net profit before taxes. And if you look at that, taking into account how much it costs to install each topology, then you see what is the actual picture of the profitability, how attractive it is. And you see that domes are less attractive a little bit than fixed tilt, but both trackers and vertical PV are very similar in how attractive they are. If you look at battery systems, both vertical and battery, again, are much more attractive than fixed tilt, but battery with fixed tilt south facing is kind of almost the same as if you don't put the battery. Why? Because your OpEx and your CapEx make it so that the extra money you get gets compensated by the extra expense in buying the battery system and the extra expense every year in maintenance. So this is not as clear cut as you would think. It is not just, yes, let's go to put the battery systems, at least not today. And that is the learning that we can take from today, I hope. And before we go to the final thoughts, I want to look at what is really going on. If we give you just some information, it's the conclusions out of what we have found out. You don't really know anything. You just know our ideas about it. So you should know why this happens, why this income is this way. And now I have made the curves of the yield of all of these systems. I made it in 3D so you can see through them. And this is south facing, the first one. This is tracker, much wider. This is dome, which doesn't look very different to south facing. And this is the vertical, where you can see one peak and the other peak. So one point here that I want to make clear is in these simulations, we try to be extremely fair. For instance, with the inverter combination we chose, if you look at AC power are grid injected for tracker, you would have clipping. But it's not here, it's not in this curve. Because for all of our calculations, in order not to take the clipping of the inverter into account, I have taken only the available energy from the DC to be more fair to trackers. However, in the reality, depending on how you will dimension your inverter, most likely you will get quite a lot of clipping with tracker and some clipping in south-facing photovoltaics. In vertical PV, this is all made with the same amount of modules, with the same inverters, and the vertical PV panels have a higher power because heteroaxial with higher efficiency. You don't see any clipping, even in the sunniest days. So looking at these generation curves, now we're going to see the income curves. And you see here the income curves of the four topologies with and then behind, without battery and behind with battery. So these peaks in the evening are the sales of the energy that the system has taken from the cheap hours of the day. So as you can see, I'm going to go back and forth. The generation for south facing is taking some of the energy and putting it into the evening sales. So this is how how we get more money out of a battery system. And now I have taken the direct comparison hour by hour of what is the income hour by hour in average of a vertical system compared to south facing. You see, in the morning, we earn a lot of money more than the south facing. Then when the sun is high, we earn less money than the south facing, but as soon as the afternoon comes, we earn much more money than the south facing. And this is the key point, because these points in time where we earn more money, if you look at the trend to the future, is going to become the points in time where price will be still high and stable. And these points in time where we don't earn as much money as south, we expect that the price of electricity in this market, this is for Germany, for electricity prices from 1st of October last year until 30th of September this year, so the most updated, this is going to become a time in the day with less and less and less price of electricity. So this is very clear where the trend is coming. So what are the summaries? First, I want you to see the cost. I have drawn a line for CapEx and OpEx at the fixed till south, and you see that every other topology has slightly higher cost, and those need to be justified, both the CapEx and the OpEx, with more income. How is this income? It is higher. That is all right. But at the end, it depends if this higher cost gives you in reality a higher financial result. And that is what every project needs to calculate by itself. We see that the fundamental profitability of vertical is today already much better than south facing in countries with a lot of photovoltaic. And for me, the most interesting point is that if you compare vertical PV or vertical PV with battery with tracker is still a better proposition. So this is the final graph where we see how much of the percentage of the investment we actually get back every year, net income. And what are my thoughts about it? You can make your own conclusions. Please do that. But to me, it is clear that vertical PV is giving you a better cost protection against the price levels of the spot market of electricity than installing a battery. So if your first worry is what to do to avoid the low cost of electricity during the noon and the central hours of the day, to install vertical will give you today a better return. It has less cost to install your system vertical as the higher cost of doing a battery or the higher cost of doing a tracker. And now, the key point I want you to remember about this is that doing vertical is a fixed installation and it is PV, a very well understood technology. When you put a battery, you have to know about battery because you put a new technological risk. And when you put trackers, you include a mechanical failure risk. So that is something you need to take into account. And if you're thinking about what you will do in the next 12 months, remember, vertical PV already has higher profitability than south-facing PV. So maybe it's something you should ask your engineers to do. Thank you very much.
Thanks a lot, Christian. So, I have one question. You also mentioned the vertical PV is a little more expensive. So, and you also said it's a little contributed by your high efficiency heterojunction modules. But what about the mounting? So, which contributes? Is it the module or the mounting solution that is contributing to its higher CapEx?
At the moment, it's mostly the mounting system.
And one more question. So, vertical PV is really looking like a very nice case scenario, but can we really adapt it to the green fields? So you cannot put vertical PV in 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 regular large scale of lands. So then because you need really a lot of gap between the modules. So then land becomes more expensive. Otherwise, you have to integrate with other applications like agri PV. So where do you see the potential? And
So this
and so
is, yeah, sorry, this is something that it is a sentence, but I don't think that behind that sentence is the numbers that support that sentence. If you look at the cost of land for long-term rental, the cost position in OpEx of the land rental is not very high. Which means that, yeah, you need to use maybe twice as much land as fixed tilt south facing, these typical systems in Germany that are basically panel to panel. But
it's
if you look at the actual cost of that, um, as I said, we are thinking about something that reduces by maybe 10% or increases 10% the OpEx. The numbers are not so high in reality.
okay.
So I will push back on that. And the one thing I didn't want to mention too much is the very obvious thing is that when you do vertical, you can do very easily dual use of the land. One of our partners just sent a message, I think yesterday, saying that they are doing the harvesting. They're harvesting in the is the first year for them. They're doing the first harvest in the vertical PV that they have installed, and they are running the
Nice.
machines just normally, no problem. So
Okay.
if you look at that from that perspective, when you have a south-facing PV, there's very little you can do in terms of agriculture. You can do some fake animal husbandry where it's honestly just fake for getting some permits because you say you are doing it. But you are covering so much of the land that is not very easy unless you do high post fixed tilt. And then the mounting system is much more expensive than vertical. So one thing with the other, I think it's really a wide array of applications, but everybody who is developing projects has been looking at land, maybe not in the right way for vertical. So they need to change the chip, look at agricultural land, maybe nearby a grid connection point, and trying to get the permits to keep using this land as agriculture and doing PV. And then it makes sense.
Nice. Thanks a lot, Christian. So that's very insightful.
Thank you very much.
Great.